Assalamualaikum and greeting to the Honorable Jury of EDIC 2016. I am Khairul Anwar from the Faculty of Computer and Mathematical Sciences, UiTM Priest Branch, presenting on behalf of my co-authors. Today I am pleased to share DockerBigLab, a containerized big data education platform for teaching Hadoop, Hive, Spark, Kafka, and MongoDB. Let me begin with the problem. For years, big data courses have depended on the Cloudera Quick Start virtual machine. That platform is now end of life. It still runs Hadoop 2.6 and Hive 1.1 technology from 2015. It demands up to 12 GB of RAM, with the budget laptops of our students simply cannot provide. Every student virtual machine slowly drifts and cannot be cleanly reset, and it offers no Spark, no Kafka, no MongoDB, the very tool industry expect our graduates to know. Our answer is DockerBigLab. It is an open source, fully containerized laboratory built from two GitHub repositories. Together, they deploy 13 containers that form a realistic big data cluster wrapped around 9 guided laboratory exercises. Any student can deploy the entire platform on their own laptop in about 5 minutes, completely free, with no licenses, no cloud, no icon, and no VMware. Here is the architecture. Everything inside the dash boundary is created by Docker on students' own machine. Repository 1 is an 8-container Hadoop and Hive cluster. Notice the Coral boxes. Students interact only through the Edge node and the Hue web interface, never directly with the name node or resource manager. This is exactly how practitioners work in enterprise deployment. Repository 2 is a 5-container Spark environment accessed through JupyterLab in the browser. Setting up takes just 4 commands. Clone the repository, download the dataset, fetch the database driver, and Docker compose up. As you can see in this recording, the cluster then configures itself completely. Hive Server 2, the metastore HDFS with 0 manual steps. Every student receives an identical environment and it can be reset in seconds. The "it works on my machine" problem is gone. The 9 labs tell one continuous engineering story. Students begin with HDFS and MapReduce foundation, progress to SQL at scale with Hive 4, move on to in-memory analytics with PySpark in JupyterLab, and finish with real-time Kafka streaming and MongoDB, the same journey the industry itself has taken from batch to streaming. So where is the novelty? Compared with virtual machine appliance, DockerBigLab deploy a genuine multi-container cluster, and each node teaching model has no equivalent in any existing platform. Compared with cloud sandboxes like Databricks or AWS Academy, it needs no account, no quota, no internet after a single 3 GB download. And compared with the many bare Hadoop Docker image online, it ships with a complete ready to adopt 9 lab curriculum. To the best of our knowledge, no other platform combines all three. The impact is real, and running today, DockerBigLab is the primary laboratory for our big data course, serving 30 to 50 students every semester. And VM-related lab failures have been eliminated. Students with low-end laptops are no longer left behind. Because of the platform is open and free, any institution can adopt it immediately, directly, advancing sustainable development goal for quality education. In conclusion, Docker BigLab transformed big data education from an outdated, resource-hungry virtual machine into a modern, reproducible, zero-cost platform available to everyone today on GitHub. Our next step is a formal acceptance study with our students. Thank you very much for your considerations.